Hey, what's up? Silas here. So, we're living in a time where I think we're going to have a whole different understanding of what history actually is. You know, the whole situation, like when you're a kid right now, most people who are born right now, if you're watching this video, you were probably born in a place where there's video or photographs of you as a child. So you can kind of have an idea to look back and say, look, this is how I was at that time. And it gives you a different understanding of time. But when it comes to the earth itself, how old is the earth? How long did it take for us earthlings to come here and be who we are right now? That thing has always fascinated me, and I'm going to read this article about the Ice Age and trying to understand how do you picture 1,000 years, 10,000 years, 100,000 years, a million years, a billion years? How do you actually picture this and communicate it to yourself, let alone somebody else? Okay, into the video. So some of you may be wondering, why am I recording this? Besides it just being something interesting to me, I think problems occur not because of what X is, but because of how we define X. Now, if you have a better way to conceptualize and understand something as nebulous or as theoretical as time in that sense, then maybe we can also apply it to our personal lives, our day-to-day lives, our history as cultures, as societies, as races, as people in that sense, and then better understand our place in all of this and maybe be able to communicate with each other in better ways. Okay, and so this is going to be me reading an article from the History Channel of the Ice Age. This is from, was updated on June 7th of 2019, and the original was March 11th in 2015. And just that alone is part of why I'm very interested and glad to be reading this for you guys today. And this is part of my series of reading things that I want to read anyway, that I think I might have some interesting thoughts on, possibly, that some other people might find interest in as well, and I might refer to back later. So with this situation, as I said, it's being updated. The information that's coming out about some of these things is amazing. We're living in the information age, and I think coming to the age of understanding, which is part of what I've been trying to do with my life, and just getting more and more information and just trying to understand what's going on. So certain things that we thought about the world are not necessarily what they actually are. The world is the world. Reality is reality. But the way we actually identify reality, problems exist not because of what X is, but because of how we define X. So there's a kind of situation where it's like, okay, we think certain things about the way we live. We think certain things about the world. And that actually leads to us making other problems. And just in general, even the best intended people, the people with the best intentions, with the information they had access to, even if they're completely open to actual information and following things, they've said things about the earth that were completely wrong, but with the information they had at the time, they thought that was right, and that's how they lived their life. Now, some things don't necessarily affect you too much. If you truly, on average, 300 years ago, thought the world was flat, how much did it really change your day-to-day life? The way you lived, your outlook on life. You're just an average person living an average life in an average location 300 years ago. How much does that really change if you know the world is what the world is? How much does it really change if you know how old the world is? If you think it's 3,000 years because the book and some religion that you believe in, or 6,000 years, or however long it is, or if you know that it's actually 14 billion years old or whatever. How does that really change your life? I don't know. To me, knowing what it is, knowing what it might be, to me is a lot better. It helps my life, and I think as we keep going on, the awareness of these things, understanding your place in this massive time scale of things, actually does help, and that's part of why I'm reading this. And one thing I am thinking about here is, do people really understand the time spans? Is it really that easy to think about a certain amount of time? We are currently supposedly coming out of a mini ice age of sorts. Do people understand these time spans? Can we really grasp these time spans? If you're talking to a child today, how do you explain to like a 2-year-old what a million years is? How do you explain that to somebody? So how old do you think the last ice age was? Some of these dates are actually somewhat more recent than we think, even though they're a lot older than what people recently have actually been thinking the world is. When you actually think about it in the span of actual existence that we know of, things happened rather recently ago that we think was a long, long time ago. So let me just get into the reading now. As I said, this is Ice Age on history.com. There's going to be links to this. An ice age is a period of colder global temperatures and recurring glacial expansion capable of lasting hundreds of millions of years. Thanks to efforts of geologist Louis Agassiz and mathematician Milutin Milankovitch, Scientists have determined that the variations in the Earth's orbit and shifting plate tectonics spur the waxing and waning of these periods. There have been at least 5 significant ice ages in Earth's history, with approximately a dozen epochs of glacial expansion occurring in the past 1 million years. Humans developed significantly during the most recent glaciation period, emerging as the dominant land animal, afterward as megafauna such as the woolly mammoth went extinct. A little aside here, a lot of information in this. This is some of the stuff that's really interesting to me. This Younger Dryas impact theory with some pieces of this meteor that's in the Taurid meteor stream hitting the different places all around the world, and one of the major impacts being on the North American continent, where there was about a 2-mile high glacier, and there's a lot of really super interesting things coming in that field that you guys can check out separately, but let's get back to the article. An ice age is a period of colder global temperatures that features recurring glacial expansion across Earth's surface. Capable of lasting hundreds of millions of years, these periods are interspersed with regular warmer interglacial intervals in which at least one major ice sheet is present. Earth is currently in the midst of an ice age, as the Antarctic and Greenland ice sheets remain intact despite moderate temperatures. Okay, there's this really cool graphic I've seen that represents the size of the Earth itself, and then in a globe that's next to it, the size of all the salt water in the Earth and all the fresh water. And just picture it in your head if you haven't thought of it. Picture how much it is. I'm going to leave a link below that I'll try to include that, or you can search online to find it yourself. And you might be surprised of the amounts of water that are there on either or of those things. Okay, back to the article. These global cooling periods begin when a drop in temperature prevents snow from fully melting in some areas. The bottom layer turns to ice, which becomes a glacier as the weight of accumulated snow causes it to slowly move forward. A cyclical pattern emerges in which the snow and ice traps the Earth's moisture, fueling the growth of these ice sheets as the sea levels simultaneously drop. An ice age creates enormous changes to the Earth's surface. Glaciers reshape the landscape by picking up rocks and soil and eroding hills during their unstoppable push, with their sheer weight depressing the Earth's crust. As temperatures drop in areas adjacent to these ice cliffs, cold weather plant life is driven to southern latitudes. Meanwhile, the dramatic drop in sea levels enables rivers to carve out deeper valleys and produce enormous inland lakes, with previously submerged land bridges appearing between continents. Upon retreating during warmer periods, the glaciers leave behind scattered ridges of sediment and fill basins with melted water to create new lakes. So did you guys know that? I mean, it's just... This is really amazing. This is the world that we live on. This is the small blue dot that we live on. And this is one saying I have about the world. It's, okay, the bad news is the world is a small place. It's a tiny place. The good news is that there's more than enough room for all of us. But then the actual news is the fact that we would probably disappear and it would just still go on. But yeah, it's still amazing. I kind of think it's amazing that what if we actually are the first actual life form to ever exist, that we're going to end up populating the entire solar system and then the entire universe? Because there is a chance that there was a start. You know, there is a chance. We've seen things on Earth have a chance. There's a chance we are just a long range of just something that's happened long, long ago. Maybe we are the last of actual sentient life that's existed in this universe somewhere else, and we're the last actual bit of it. Maybe we're somewhere in the middle. There's all these kind of different opportunities, and it's just stuff to kind of think of and possibilities out there. Okay, back to the reading. Scientists have recorded 5 significant ice ages throughout Earth's history. The Huronian, which is 2.4 to 2.1 billion years ago. The Cryogenian, which is 850 million years ago to 635 million years ago. The Andean-Saharan period, which is 460 to 430 million years ago. The Karoo, which is 360 to 260 million years ago. And the Quaternary, which is 2.6 million years ago to the present. That's where we are right now in the Quaternary. So remember that word, quaternary. Quaternary. Okay, back to the reading. Approximately a dozen major glaciations have occurred in the past 1 million years. The largest, which peaked 650,000 years ago and lasted for 50,000 years. The most recent glaciation period, often known simply as the Ice Age, reached peak conditions some 18,000 years ago. before giving way to the interglacial Holocene epoch 11,700 years ago. Just think about that. This is really not that long. If you're really just like, let's say, let's you just think about human type of things, and maybe 1,000 years is equivalent of 1 year of humanity. Then this is like when the Earth was 11 years ago, like 11 years old ago. Then like 18 years old ago was when the peak of the Ice Age was, and then you're looking back. It's just I don't know. There's different ways people can try and relate and understand these different time things, and what are good ways that you get to think of and discuss certain times. That's part of why I read these things, because when I first start hearing these numbers when I was younger, it's hard to actually understand these lengths of time. What are good ways you think to be able to talk to people about these things, about these epochs, about these great lengths of time when we are such relatively short-lived beings? Okay, back to the reading. At the height of recent glaciation, the ice grew to more than 12,000 feet thick as sheets spread across Canada, Scandinavia, Russia, and South America. Corresponding sea levels plunged more than 400 feet, while global temperatures dipped around 10 degrees Fahrenheit on average and up to 40 degrees in some areas. In North America, the region of the Gulf Coast states was dotted with pine forests and prairie grasses that are today associated with the northern states of Canada. So yeah, that's what I was talking about before, just those massive ice sheets. This thing about 400 feet drop in the sea level. Just think about going to the coast somewhere of average sea level place and thinking there was 400 more feet of actual distance to go. That's a lot. It's a whole lot. It's a big effect. Now I'm not quite sure exactly how this would appear. Maybe if you go to somewhere where there's a reef, it would be a 400-foot drop down. But if there's just a slow sloping beach, would it still have to go down 400 feet before you actually get to it? I don't know. Back to the reading. The origins of Ice Age theory began hundreds of years ago when Europeans noted that the glaciers in the Alps had shrunk. But its popularization is credited to 19th century Swiss geologist Louis Agassiz. Contradicting the belief that a wide-ranging flood killed off such megafauna as the woolly mammoth, Agassiz pointed to rock striations and sediment piles as evidence of glacier activity from a destructive global winter. Geologists soon found evidence of plant life between glacial sediment, and by the close of the century, the theory of multiple global winters had been established. A second important figure in the development of these studies was Serbian mathematician Milutin Milankovic. Seeking to chart the Earth's temperature from the past 600,000 years, Milankovic carefully calculated how orbital variations such as eccentricity, precession, and axial tilt affected solar radiation levels, publishing his work in the 1941 book Canon of Insolation and the Ice Age Problem. Milankovic's findings were corroborated when technological improvements in the 1960s allowed for the analyzation of deep-sea ice cores, which helped pinpoint periods of glaciation. And this is a cool thing out there. This is something that I think people might not necessarily realize about science. It's not a religion in that sense. I know some people might have more of a religious faith and belief in it, but it's a system. It's a way of coming to conclusions about certain things. So it's kind of cool here to see like a mathematician help play part in this. As long as you get the data, as long as you can get some information, you can study it, it's refutable by certain ways. Other people can come and confirm in whether you are right or wrong. You can see people can come up with ideas at certain time, then later on you find technology that can actually find that right, and then you adjust to it. You can have theories out there. Necessarily theories, hypotheses, these things are not all made equal in that sense. It's not just, oh, we have to listen to specifically the scientific experts. Technically, a scientist is doing studies, he's doing research, he's doing things that anyone should be able to actually, with access to those same things, that same amount of data that that person took in, and the same tools that person took to make those tests, the same formulas that that person put in, anyone should be able to repeat that kind of data and find those same results for it to be a very solid theory, to be very good science. And that's one thing I really do like about the scientific method and the things that it's given us in this world. Okay, going back to the reading. Along with solar radiation levels, it is believed that global warming and cooling is connected to plate tectonic activity. The shifting of the Earth's plates creates large-scale changes to the continental masses, which impacts the ocean and atmospheric currents and triggers volcanic activity that releases carbon dioxide in the air. Okay, there's one thing here. Again, I was listening to this book by Graham Hancock, who has been, I've heard about him some time back, and he's talked about how he's had some big detractors in the archaeological community due to his questions about how old the world is, mostly focusing on how old human civilizations are. So he talks about how they might have been pre-ice age kind of civilizations that were actually a lot more advanced than we're thinking. And I'm not talking about super advanced, doing all these super things out there like flying around the world in that sense, like talking about that helicopter that might have been on one of the hieroglyphs in Egypt. I don't know, he doesn't mean that advanced, but he's just talking about certain knowledge levels that we are unaware of. A community that might have gone around and spread certain technology and certain awareness to different communities because there's certain things that are familiar in other places. Though I don't completely agree with all that. Some of that I'm thinking it's like we're all humans, we're all living on Earth, we're all been there in those areas for around the same time. Chances are most of them would be able to look up in the sky. There's not that much light pollution, seeing the same stars. And as a sentient human being, we might have the same reactions and have different people come to the same conclusion that there is something important out there. There is this question of what's happening with death, what's happening with life, and actually go in and research more about what's happening out there. That's why you can see certain things coming down. And then when it comes to mathematics are the same anywhere. 1 plus 1 is 2, whether you're living in Timbuktu or living in I don't know, I wanted to rhyme something with 2 from somewhere else. Anyway, think of some other location that ends with 2. Anyway, so back to the reading. I think we're back to the reading. Yeah, there might have been something I was trying to get at, but I kind of lost my track of mind. I was going in that digression. But, oh no, that's what I meant. The plate tectonic thing. Just the Earth itself is massive. The plate tectonics, the way pieces of the Earth actually just go down and grind, go down under each other. And there's this really cool thing on Discovery Channel. Was it Discovery Channel or National Geographic? One of these news channels. Documentaries are really stepping their game up. If you haven't been watching documentaries lately, get back to that. There's one where they say draining away the sea or draining away the water, and they suck all the water away and do these with 3D mapping and these sonar mapping and better ways of mapping the actual bottom of bodies of water, be it the coast, be it the ocean, and they suck it out and then they show how the actual surface looks down there. And there's some really cool things out there. But I think the main thing I wanted to talk about here before we get back to this reading, and we only got 2 more paragraphs left, so we'll almost be done, was how supposedly during this impact event, with the Younger Dryas impact event, when the pieces of a comet, possibly pieces of a comet, hit different places over a length of time passing through this torrid meteor stream, there was such a change to the Earth's atmosphere that apparently the Gulf Stream actually ended. There was so much, I think they said so much of this ice material was actually thrown in. There was a lot of defreezing material, a flash of defrosting of material, that it fell into the ocean. And somehow with the temperatures and the changing, this is I just listened to this book a bit ago, so you can go back and look and get the actual information. I think it was during that time. But the Gulf Stream ended. And the Gulf Stream from Finding Nemo, where the turtles are swimming in. This massive Gulf Stream, this massive river torrent of water that's just going around the ocean that affects the climate so much in so many different ways, was actually just spinning out there, and it stopped because there was so much cold water added to the temperature. And I need to do a separate video on this thing because it's just really cool, interesting stuff. And supposedly when the biggest pieces that hit came in through the atmosphere, what you don't understand is, I didn't really realize this until I heard it in that book, but it just makes complete sense because the atmosphere is actually some kind of globe itself. I know it's not like the ozone layer, it's not like a dome, a physical dome holding things in like a biodome or sort, but there is some kind of levels, there is something that holds in, there actually is surface, so there is layers. So when those huge chunks of space debris come in, they punch a hole in and they push the air out of the way, and they actually cause a hole, a tunnel of this no actual air, and it pulls in space. So it just pulls in that sub-zero freezing space, and that just smacks into the atmosphere. There's so many cool things about anyway, back to the reading. One significant outcome of the recent ice age was the development of Homo sapiens. Humans adapted to the harsh climate by developing such tools as a bone needle to sew warm clothing. Is that supposed to be sew, or might be past tense maybe? Okay, anyway. And used the land bridges to spread to new regions. By the start of the warmer Holocene period, humans were in a position to take advantage of the favorable conditions by developing agricultural and domestication techniques. Meanwhile, the mastodons, saber-toothed cats, giant ground sloths, and other megafauna that reigned during the glacial period went extinct by its end. The reasons for the disappearance of these giants, from human hunting to disease, are among the Ice Age mysteries that have yet to be fully explained. Scientists continue to study the evidence of these important periods, both to gain more insight into the Earth's history and to help determine future climate events. So that's it for now. On the screen has been a speed drawing of an illustration I did. I had this up on the video that was a response to the objections that people normally have to the non-aggression principle, which I think you should check out if you haven't checked out that video. The zero aggression principle is something that helps me guide myself around my reality tunnel, made me come across to that realization that most problems occur not because of what X is or because of how we define X and coming to certain things and certain understandings. But anyway, this illustration is about just showing how people might come with new information, new ideas, better ways of doing certain things, but because you're so stuck in your ways, and those ways don't necessarily not work. Those ways might be better than doing it in the ways that were previously done. But in so many cases, those actual ways that so many people are so stuck on doing would not have even come to be if people before them hadn't accepted these other new ways of doing things. So just have an open mind to certain things, be skeptical about certain things, be willing to actually go in there and say, I don't know if this is the best way of doing this. I'm not quite sure if this is enough information to say this is completely true. And when more information comes around, question it, check. Is that something I'm actually going to give some time to? I'm actually going to consider that as an actual possibility. And I think it will make for a better place, a better world, and a better life for you. And I'm thinking of like singing like Heal the World now. Make it a better place for me and anyway, like, share, and subscribe. Goodbye. Oh, one more thing. The reason I was actually even anti this thing is because there's merchandise. You can buy merchandise with this design on it, and I will have a colored version coming up sometime next year. Goodbye.